I've got a cute little diagram here that I drew to describe what the idea behind a limit is pretty much. So you got some little function here. This is y is equal to f of x. It's so redundant saying y is equal to f of x. It's just like, yeah, dude, this is the function. Y is f of x is y. Why do I say y twice, or why do I say f of x twice? Anyway, this is the x-axis. This is the y is equal to f of x axis. So this is the function, and what's gonna happen? So let's just say we got some limit, yeah. So the limit as x approaches a of f of x is equal to L. That's the idea. I don't know why they use this notation, like L. I guess that L stands for limit. I don't know. Actually, it probably does, and that just occurred to me now. So, it's the limit. So, yep, as x approaches a, and a is this point, some value of x on the number line. So let's just say this is like, I don't know, 3. And it's a value of x, yeah, because it's on the x number line. And what happens is you're wondering where what the value of y is going to be, or L, for example, because sometimes you have like a hole here. I don't know, piecewise functions, you know, the ones that have restricted domains. And if you don't know what a domain is, it's basically all the values that can span x, and the range is all the values that can span y. But that doesn't matter, that's a topic for another video. But basically, yeah, this could be a hole, and this could be actually not actually a part of the function's domain. So when you take the limit of the function in that domain, it actually may approach a hole, and that limit is therefore not, like, you know, you can't find the limit basically. But yeah, that's the basic idea behind the limit. So most limits actually will be able to be solved algebraically, but if not, there's no, all hope is not lost. There's a magic rule for pretty much every single kind of limit problem where you don't need to know the algebra or the skills to do them. However, you should be able to do it, because it's mostly just being able to factorize trinomials. Yeah. So, and you want to know what that magic rule is called? I'll just introduce it here, and I'll probably talk about it in the next video or something. But it's called L'Hopital's rule. You can pronounce it however you want. It's like Al Hospitals. People have different pronunciations, but basically the idea behind L'Hopital's rule is you've got like the limit as x approaches, I don't know, well, it's usually as x approaches 0, because whenever you plug in 0, the answer is 0 of f of x. And if you get an answer such as 0 over 0, or infinity over infinity, that's called what you would call indeterminate form. This is not like x or y, by the way. Sorry, that's actually very bad of me. This is not x or y. These are just two examples of answers you would get if you So if you plugged in 0 into a function of x, so let's just say that's like x squared, yeah? X squared over, I don't know. I can't think of a function right now. But if you have an answer of x over x, like 0 over 0, it's indeterminate. And if it's infinity over infinity, it's also indeterminate, which means that you can use L'Hopital's rule. Now, this is what I've been trying to get to for the entire video. And this is like, it's got some more rigorous mathematical proof as to why it is. I can't remember where it comes from, to be honest. I might tell you another time. I don't think I'd be able to prove it, honestly, because I'm not that much of a genius. But here's the idea. So you got the limit as it approaches f of x, and let's just say your limit is a quotient, which it should be if you're getting 0 over 0. So you basically take the derivative. You take the derivative of top and bottom, so if you take the derivative of f of x, don't use the quotient rule. You got to take the derivative of f of x alone, and then leave it, and then you take the derivative of g of x alone. So it's two different, like, values on the top and bottom. So you've got like x squared plus 2x plus 1, and this is like 6x squared plus 3x plus 9. I don't know. Obviously, you wouldn't use L'Hopital's rule in that case, by the way. But you would take the derivative of the top normally, and you'd basically just using the power rule, and you take the derivative of the bottom alone. And that should give you an answer, and if it doesn't, here's the neat trick about L'Hopital's rule. You can take the derivative again. How sick is that? You can do it over and over and over again, as long as you keep getting this answer. If you keep getting this answer, logic says, use L'Hopital's rule again. Anyway, this is just an introductory video to limits. I didn't actually really teach anything. I sort of just talked out of my rear end, but nevertheless, in the next few videos, I'll be explaining how to do some limit problems and limits as x approaches infinity and other kinds of limit problems. I'll be demonstrating L'Hopital's rule very soon. Thanks for watching. Peace.